Hey, how you doing? It's time to look at a particle on an inclined plane. Here it is, particle on an inclined plane. Okay, let's have a look. Okay, and I'll just talk to you a little bit about it. So you've got particle P of mass 0.5 kilograms is on a rough plane inclined at an angle alpha to the horizontal where tan alpha equals 3/4. Now you might think that's an awkward way of phrasing it, but it's been phrased that way for a reason. I'll show you that in a minute, okay? Let's read on. The particle is held at rest on the plane by the action of a force of magnitude 4 newtons acting up the plane in a direction parallel to a line of greatest slope of the plane as shown in the diagram. There's a lot going on with it, isn't there? So basically this particle P, normally it would roll down the plane, wouldn't it? Okay, but there's something keeping it there. Right? It could be someone just holding it in place, some sort of pushing force, but it's a magnitude 4 newtons and it stops it from rolling down the plane. Now what does this bit mean? In a direction to a line of greatest slope. Let me show you. This is a laptop, but they come in handy for this sort of thing here. See what I've done there? I've just modelled this laptop as the inclined plane. Okay, so there we go. I'm just going to turn it like that. Right. So this is the plane. Okay, but notice it's not just a one-dimensional plane, is it? Okay, you can actually go off in plenty of different directions. Imagine this is a mountain. Okay, and you walk from the bottom of the mountain to the top of the mountain. Now, what do? Do you just go up the greatest slope path? No. What you probably do is find some sort of trail that will make you go around like this. I'll just rotate the laptop so you can see what I'm doing there, and eventually you get to the top. Okay. What I'm saying here, though, is that if you took this path, it's a longer path, of course, than this path, but actually this path is steeper, okay, than this path. If you zigzag all the way up, then you're not really going to feel that much in terms of your walking, okay, because you're choosing a least steep path, okay, a longer path but steeper. If you walked horizontally across like that, of course, you're not changing your vertical height at all, so you're not going up or down, of course. So what does this bit mean? Line of greatest slope basically means from here to here. If I just rotate it like that, like this, but you can see if I just do away with the laptop, okay, that's kind of what you see when you're looking at it head on, okay? So this angle there, alpha, that represents the angle in which I've got my laptop open, okay? And then that will be the line of greatest slope. In terms of the exam question, you can ignore that bit and just look at the diagram, okay? But I just wanted to explain a little bit what that actually meant, okay? Then this, okay? What I'm going to do is I'm just going to move that there a little bit to give myself some room. So the tan alpha equals 3/4. So why have they actually given it to us in terms of this awkward looking expression? Okay, why don't they just say alpha equals this angle, whatever that happens to be, 30 degrees or 45 degrees or 60 degrees or 20 degrees, something like that, okay? Well, the reason is to help us actually with our calculations. Now what I'm going to do is I'm going to draw out a right angled triangle, okay, like this, and I'm going to label that as alpha. And I know, of course, that alpha is going to be an acute angle. It's going to be somewhere between 0 and 90 degrees. And if I use my knowledge of trigonometry, tan is opposite over adjacent. So that means 3 represents the opposite, the 4 represents the adjacent. That's essentially what the tangent angle means, okay? It's set up as a ratio that this divided by this is the same as the tan of the angle. That's the definition of the tangent of an angle, okay? What I'm going to do is I'm going to work out the hypotenuse, which is 5. It's a 3, 4, 5 triangle, okay? A Pythagorean triple. 4 squared plus 3 squared, 16 plus 9 is 25, square root of 25, 5, okay? And now what I'm going to do is I'm going to work out an expression for sine alpha and cos alpha. So sine alpha is 3/5, opposite over hypotenuse, and cosine alpha, cos alpha is equal to adjacent over hypotenuse 4/5, okay? And if you've done these sorts of questions before, you'll know that when we're resolving in parallel and perpendicular directions, then we come up with expressions of sine alpha and cosine alpha. So in this question, we don't actually need to know what alpha is at all. We can just use sine alpha and cosine alpha. If you use those somewhere, sometimes there's a method mark that's actually available, okay? Let's have a look then. I'm going to put some forces in now. So I know that the weight downwards is going to be mg. So 0.5 kilograms is the mass, so 0.5 g, okay? And I know that there's going to be a normal reaction here, so I'm going to label that as normal reaction. And the particle is on the point of slipping up the plane. Well, what does that mean? On the point. Well, it means strictly speaking, the acceleration is 0. It's not actually moving. It's about to move. And if it's about to move, it will be moving in that direction, if it does actually move. So what that means is, if it's about to move up the slope, the frictional force, because it's a rough plane, will be down the slope. Okay, so there's going to be a frictional force down the slope there. Okay, now just give me a moment. I'm going to draw a slightly better diagram. I'll be back with you in a minute. There we go, I'm back again. So I've just redrawn the diagram. Okay, the reason I wanted to redraw it is because I'm much happier putting this force of 4 newtons on that side. Okay, you can do that because forces act like vectors. Okay, when you've got a direction as well as a magnitude. Okay, and so my diagram just looks a little bit neater like that, I think, anyway. And I've given myself more space between here and here, because what I like to do with this is I like to put on what I call the weight triangle. I've not spoken to you about this before. Let me just show you what it is. It's a triangle. It's going to help me to split this force, the weight, into parallel and perpendicular components. So at some point I'm going to have to know what the parallel and perpendicular components of this weight force are. Okay, using similar triangles, that angle will be alpha as well. Okay, so using that triangle and that triangle there, you can work out the angles alpha. I'm not going to show you that now because it's more a key stage 3 thing. Okay, and then what I'm going to do is I'm going to resolve. Okay, I'm going to resolve in 2 different directions. I need to resolve perpendicular to the slope, and I need to resolve parallel to the slope. Doesn't matter which order you do it in, as you'll soon see. Okay, so perpendicular to the slope. So you've got R, which is perpendicular, and the normal reaction is always at right angles to the direction of motion there, to right angles to the surface. So R, and then minus in the opposite direction is the weight, because if you break this up, the weight on the hypotenuse, I'll put it there on the right angle triangle, is down the slope and then that way kind of into the slope. Of course, the object can't fall through the slope, can it? That's why it will go down the slope if it does. So it's this bit there I need. So that's 0.5 g, and because that is adjacent to the angle alpha, it's going to be cosine alpha. Okay? So 0.5 g cosine alpha. And that's equal to 0. Forces are balanced because it's not moving in a perpendicular direction. So what that means is that R is just equal to 0.5 g multiplied by cos alpha, which is this, 4/5. Like I said, that comes in handy, doesn't it? Okay, that's a nice easy one. So a fifth of 0.5 is 0.1 times by 4, so that's 0.4 g. Now, because I don't need to work out what g is, I'm just going to leave it like that, okay, for the moment. Right, what next? We need to resolve parallel to the slope as well. Okay, so parallel to the slope. What's happening? So as I said, it's on the point of slipping up the plane, isn't it? Let's just put that arrow back in again. Okay, if it does go anywhere. So I'm going to take up the plane as being positive. So I've got 4 is positive. Subtract, obviously, the frictional force the other way, but also subtract the weight component, which is that bit there. And because that is opposite angle alpha, that's going to be 0.5 g sine alpha. Okay, and that's equal to mass times acceleration, which is 0. Okay, don't forget it's not moving, it's on the point of moving, so its acceleration is 0. Okay, the sine alpha I can write as 3/5. Okay, so I'm running out of space here, aren't I? I don't like it when that happens. So I'm going to save a bit of room, so I'm going to put the F onto that side already, and I'm going to leave everything here. So I'm going to 4 subtract and then 0.5 g sine alpha times 3/5. Okay, 0.5 g times by 3/5. Okay, and that's going to be 4 subtract, and that'll be 0.3 g. And because that's a bit awkward, I'm going to work out what that actually is. Okay, so 4 subtract 0.3. Remember, g is 9.8. Okay, and that's going to be 1.06. 1.06 newtons. So should we just put in here what that would be then? So 9.8 multiplied by 0.4 is 3.92. 0.92 newtons. Okay. Find the coefficient of friction. Remember that is mu. Yeah. So for that we have to work out mu using F equals mu r. I can just about squeeze something else on here, which I'm going to do. Okay, so this is very tight, isn't it? I don't think I've left it quite so tight in one of these presentations before. F equals mu r. Therefore, mu is equal to F over r. Frictional force is at 1.06 divided by 3.92. Okay, so 1.06 divided by 3.92. Right, and that is 0.27. And I'm going to keep it as 0.27 to two significant figures, because whenever you use G, like here, you should be rounding to two significant figures, because 9.8 is two significant figures as well. Okay, so that's that part of the question done there. Because I've got no more board space, I'm going to pause the video there and I'll get back to you when I've restructured this. Okay, so I've just adjusted a little bit. Wasn't long for you, of course, but it took me a minute or two to do this. So what's going on? The force of magnitude 4 newtons is now removed. Got to find the acceleration of P down the plane. Right. So with this removed, I'm just going to use a different colour actually to cross that out. That means that force is no longer there. It's moving down the plane. So this acceleration arrow, I'm going to put down that way now. I'm going to cross that out, and the impact upon that is that the frictional force is going to be up the slope now. Okay, so remember, friction always opposes the direction of motion. Okay, so the frictional force is now going to be that way up the slope. I hope you can see that clearly. All right, so to recap, it's moving down the slope. We've got to find the acceleration. Frictional force will be the opposite direction. Okay, and of course there's no 4 newtons. Okay, so back to my preferred writing colour for this question now, back into blue. We've got to set up an equation of motion again, using forces I mean. So parallel to the slope, or parallel to the plane, and so because it's moving downwards, that's going to be positive, so that means that the weight bit is positive, so that is 0.5 g sine alpha, and then opposing that is going to be the frictional force. So subtract the frictional force, which we know is this 1.06. Friction doesn't change, by the way, because remember, this is the maximum value of friction found when it is on the point of slipping. Once it actually moves, the frictional force is always at its maximum. Okay, and because the surface has not changed, the normal reaction has not changed, the frictional force has not changed either. So throughout the question now, the value of F to use is 1.06. Okay, so we've got that, subtract this is equal to mass times acceleration. So that's 0.5 times by A. Okay, so 0.5 g sine alpha. What was that again? 0.5 g sine alpha. So that was 0.5 g times 3/5, 0.3 g. Okay, so 0.3 g subtract 1.06 is equal to 0.5 A. Okay, I'm just going to work out A is. Put my calculator over there. So 0.3 times 9.8. Okay, subtract 1.06, and then divide that by half, so times by 2. Well, we've got 3.76. So A equals 3.76 meters per second squared. Okay, that's our acceleration down the plane. Right, that's that question done. Okay, hope you got a lot out of that. Thank you for watching, and I'll see you again.